So today we're going to be looking at a very simple dynamic programming problem. It's called climbing stairs. It's part of Neetcode 250, and it's usually one of the first dynamic programming problems you'll encounter. So you're given an integer n, so the input. This represents the number of steps to reach the top of a staircase. You can climb with either 1 or 2 steps at a time. So that's a very simple problem. Broken down into 2 choices, either 1 step or 2 steps. So return the number of distinct ways to climb to the top of the staircase. So example is equal to 2, output is 2, and that equals 1 plus 1, or take 2 steps. And that is very simple. So I'm going to first do a very simple way, and then the second one is also very simple, but it's slightly more optimized. So the simplest way is to make a vector of ints to keep track of the distinct ways to reach the nth step all along this vector. So dp and then n plus 1 will be the size. Let's use the correct ones here. So after that, all we need is the base cases. So these will be the first step, which is 0. And there's only one way to end up there, and that is you start off on it. You can't reach it any other way. And then the first step, again, there's only one way to get there. From the 0th step, you have to take 1 step to get there. Can't take 2, otherwise you'll overshoot it. Then you just have to do a loop over the vector. So int I is equal to 2, because again, we have these 2 base cases already. And we do I is less than or equal to, because we want to include it, n, and then plus I. And then this is very important here. So the ith iteration is always, as you can see here, I. So let's take it for 2. So we do this case plus this case, that is I minus 1 and I minus 2. And that would equal to 2 distinct ways, which would be correct for this example here. So we can just do dp of I minus 1 and plus that to dp of I minus 2. And then all we have to do is return the vector with the input at n after we loop over it, because we're filling in the vector. Unless there's any syntax errors, that's all. Oh yeah, return. That's all that should need to be done for this one. And yeah, it seems to be correct. So it's O of n, time complexity. However, memory, we are storing the whole vector as well. So O of n also, but there is a slightly more efficient way to do this. So let's start that off here. So we don't actually need the vector here. All we need is a integer to keep track of back 1. This is the step back 1 from the current place, and this would be equal to 1, it's the base case. We're going to do back 2 also, and this is 1 also, and int current is equal to 1 also, and I'll show you why later on. Then we're obviously going to have it ported again into I is equal to 2, I is less than or equal to n again, and then we just need to increment I. So we need to actually update current. So current, when I is equal to 2, it would be back 1 plus back 2, back 1 plus back 2. But we also need to update back 1 and back 2. I'll start with back 2, needs to be updated to back 1 on every iteration, so that it's kind of sliding window effect, so that all of the values move forward together. back one also needs to be current, updated to current. And then all we have to do is return current, and that is finished. So now it's not O of n memory wise anymore, it's O of one, it's constant, because we're not allocating that vector and keeping track of all of the intermediate results. So we can submit that. It is slightly better. Again, both of these are bottom-up approaches. I find them a lot simpler than the top-down, but we'll cover those later on.